G'day everyone, how's it going? Really excited for today's interview. I've got Mr. Dufresne, the Mr. Dufresne from EPT Clean Oil, who's come to talk to us all things sort of filtration, asset management, looking at lubrication as an asset. So really excited to get his insight. He's obviously got a lot of knowledge and a lot of experience within the industry. Really excited to get his take on it. And so maybe if we just dive straight in, if you wouldn't mind, because this will help introduce you and EPT, could you please help tell the story of, EPT, the resin media filtration technology that you guys are probably most well known for, how that got started. I know your family was very involved. So maybe if we sort of tease that out, that'd be a really good starting point.
Sure. Well, nice to be here. Thank you for the opportunity. In 1992, I was working in Toronto, which is sort of the financial district of Canada. And my dad was fleet maintenance manager for a large energy company, gas transmission company in Canada that ran 200 turbo compressors. And they were suffering from a lot of failures where the root cause of failure was determined to be lubricant and lubricant deposits. And at the time, we didn't use the word varnish back then. They called them coking, they called them lubricant deposits. Some people started to call them oil varnishing. And he was really fortunate to have supervisors that gave him a very wide latitude in solving the problem. And what he discovered very quickly was that the oil analysis was not measuring anything regarding what was causing the machines to fail. And when you talk about failing an RB211 or an LM2500, this is big money, right? Huge money. These assets are supposed to be running like 98, 99% of the time was their targets. So when he dove into it, he started doing a lot of reading and a lot of research. And what he figured out was that oxidation material is the root cause of oil failure. And in the case of their machines was also the root cause of equipment failure. And as soon as they realized that the lubricant testing and the maintenance was really removing particulate and not addressing this root cause, it led his investigation to what can we do. So he read some papers on ion exchange that had been used out of its traditional application, which is water purification, and started experimenting. And he with 200 gas turbines, he did a third and a third and a third, trying different techniques at different turbines, and very quickly discovered some things worked really well, some chemistries worked excellent, and other chemistries didn't work very well. And then some sites were so far out of range, they were even beyond what ion exchange resin technology could do. So after about 2 years of research, he figured out what was working really well in one of his test regions and then implemented that on a fleet-wide basis. And the cost savings were dramatic. They went from 4 complete turbine failures per year to 0. They went from having to replace oil reservoirs every 4 to 6 years to no longer having to replace them. So quite a dramatic response. So I remember the day very well. He called me and he said, "Peter, I got a call from the U.S. Department of Defense, and they asked if we'd be able to help them on the same problem that TransCanada fixed."
Yeah.
So what do we do? And, my dad's a brilliant engineer. I'm a young up-and-comer guy at the time, didn't know a lot. And I said, well, let's go take the meeting. So we went and had the meeting, and we get to the U.S. Navy base in this case, because it was for the carrier fleet. And they wouldn't let us on because we were Canadian. And they said, well, that's alien. You're an alien. And I said, we're meeting so-and-so. And he said, I don't care who you are. You're not getting on my base. So we did the presentation right in the guard shack. Okay.
Nice.
And within a half an hour, they were convinced and they said, let's do it. When can you do a demonstration? We said 8 weeks. So we came back 8 weeks later with our demonstration unit, and we couldn't get back. We couldn't get on the base again. They said, no way, you're getting on our base. So you gotta love the resourcefulness of the Navy. So they brought to the parking lot power, lights, a building, and we did the demonstration in the parking lot of the largest West Coast Navy base. And we did it, and it was working fantastic. And then I had the genius question. So what volume are you guys dealing with anyways? And they said, we got 100 cubic meters. And I was like, 100 cubic meters, and we're flowing like 4 liters a minute, and I got to filter it 6 times, right? So I'm doing the math in my head going, sorry, this is going to take 20 years. So we did some on the site discussion and negotiation, and they gave us 12 weeks. And in 12 weeks, we had a large machine. My dad mortgaged his house to build it. And the paint was wet on it. And they were calling like every day, where is it? Where is it? Where is it? So it didn't even have a finishing coat of paint. It just had primer paint on it. And I drove it down to the military, and I didn't even ask to get on the base this time. I just threw the keys at my contact, and he took the truck on the base. And that was the start of EPT. Our first customer was the US Navy. And we thought we were off to the races. Incredible customer, right? We're going to hit the big leagues. But the truth of the matter was, there was only 2 aircraft carriers at that facility, and because they're all spread out, decentralized. So we did 2 ships, and it took us about 8 years to do them all. And then they were on a cyclical basis after that. But we had 2 customers at that point. We had the gas transmission company in Canada, and we had the US Navy. And although we had a great technology, we really didn't know what we were doing from a business perspective. So that was really interesting. So we've had this journey over 30 years now. My dad has since retired and enjoying golf, but it took us 30 years, and we've refined the technology to a point where its performance is just light years ahead of anything else like it on the market. And I just know, based on the cost savings that people are achieving, that it's very likely going to become the industry standard approach, because there's really too much money involved to do things halfway there. Half measures are 0% effective, right? Mm. And this is where we're at. So we've gone after, so our third customer was the largest power plant in the United States. And then it went to the second largest in the United States, the third largest, it went to largest in Europe, the largest in Asia. And then we've been just filling in the gaps really over time, one customer at a time, to make sure that they get really good results.
Yeah, that's a kind of a really cool origin story. That's really neat. I don't imagine that there's too many companies that start out with that much of a bang, to be honest. Maybe just to throw in a initial technical question, because like you said, a lot of people would be familiar with, let's say, resin media filtration from the water treatment industry, yeah, where it kind of originated, taking out contaminants. Many people would be familiar even with like home water purification systems, like removal of hardness, if you like, from the water. How exactly does it work in an oil system, and what are the major differences?
Well, the major differences are that in the water application, people don't really care about precision to the same degree, because they're regenerating the ion exchange resins over and over and over and over again. So even if it's at 90% or 80% capacity, we don't care, because they'll regenerate it to 100% within the first week of operation, and everything resets. But in the lubricant application, we are using virgin resins. We're not regenerating them because it's really not cost effective to do it at a local level. I mean, it's technically possible for like $500,000. You could build a regeneration plant to regenerate ion exchange resin used in lubricant applications, but it's really not cost effective at this point, right? So the first major difference is quality, because we're not using, we're using virgin product every time.
Okay. And then maybe this is kind of a very base level question, but our objective with filtration technologies is at a very, very basic level. I want to take the bad stuff out, and I want to keep the good stuff in. Now, let's say, for example, when most people conceptualize filtration technologies, they're probably thinking of particulate filters, right? Which are only able to discriminate based on particle size. So it's kind of like taking a very blunt instrument to an application. What I understand with resin media is that we're trying to use, let's say, charge, right?
Okay.
And polarity to
Okay.
be selective about the type of contaminants that we want to remove. And that's because most, oxidation products are polar. But then, of course, there are a lot of additives that are also polar because they're, surfactants or surface acting. How are we able to selectively remove the oxidation byproducts without completely stripping out an additive package?
This is a great question. When we started only with fire-resistant synthetic lubricants, or FRFs for short, and they contain no additive. So it's like antibiotic going to the doctor. They could use a broad spectrum antibiotic and be as aggressive as possible with the chemistry because there's really no additives to remove. In fact, the fluid is pure additive, okay, if you want to look at it that way. So as we moved into additized products, we first started with R&O lubricants used in rotating equipment.
Yep.
And those are about 98 to 99% pure base oil and only 1 to 2% additive, of which 90% of that's comprised of antioxidants. So when you talk about these polar additives, they're very limited. Yep. And they're often short-lived. So so we've had to detune the range of the contamination we're removing so that we do not remove the additive in the oil. This is one of the reasons why we test every site before we apply ion exchange resin, just to confirm to 100% degree of certainty that we don't remove additives. And it's kind of it's almost an unnecessary exercise if you've had the same brand of oil. We know brand A, B, C, D, and we've done them 100 times and they don't remove the additive. As we move into more additized product, like AW oils, where there can be, say, 5% additive, it's becoming more and more of what the science is about when engineering ion exchange resins. And that's actually where it's led to. We can't just take resins off the shelf and put them in a filter and expect them to work, because the variability present is huge, okay? So we're lucky as specialists in this field. We use enough ion exchange resin that we have our own ion exchange resins made just for us, right? So then we can control the chemistry, and it's really the tuning both on the chemical and physical side of the ion exchange resin bead so that we get exactly what we want, okay? So we are tuning the reservoir just like antibiotics are tuned. You want a very broad spectrum or you want a very narrow spectrum programming on that resin. Okay.
Cool. So, I mean, that certainly explains one of the differences because, let's say, for example, I go to the EPT website. I'll see a range of different filters available. And so that explains some of the variation. The other question I was going to ask you, though, is because the variation in products seems to vary also depending on lube oil type. So you talked about R&O and anti-wear, but let's say, for example, it seems like there's a different resin exchange filter for, let's say, a phosphate ester versus jet oil versus a mineral oil versus a synthetic. Now, is that also down to the fact that all of these different turbine oil types degrade in different ways?
There's a little bit difference, actually. Phosphate ester, the breakdown pathway starts with water, right? Predominantly, and then it manifests itself into full oxidation and condensation reactions, which are really unexpected. In the mineral oil applications, it's much more uniform in terms of what's happening, right? We have oxidation that's produced, and the antioxidants, the primary antioxidant, normally in amine, will capture that radical so that whatever it comes into contact with from that point forth is unreactive, right? It doesn't remove it. It just puts like a blanket around it so that it can't react anymore. And then that process continues over and over again. But what we're finding is that there's some really interesting aspects to that. If you let this process be completely unmanaged in your system, it consumes more additive, which is sort of counterintuitive, but the rate of breakdown has some relationship to the existing accumulated level of breakdown. Okay, so it's not perfectly linear. It's more of an exponential curve. So what we find is that users quite often do nothing for the first half of the oil life cycle, except remove the particulate. And then in the second half of the life cycle, that oil performance is impaired. Its physical properties are different. And that makes no sense to me. Like, you would never do that on your sports car, right? Like, no, I would always want the best quality lubricant at all times in that, assuming you're not driving an EV. But when you get into $100 million machine, why do we accept impairment in quality and performance over that second half of the life cycle? It makes no sense to me, but this is the consequence of leaving chemistry unmanaged.
Yeah, that is interesting. The other thing that I've always found a little bit interesting, and this maybe goes more to sort of the site level, is like you said, $100 million piece of equipment, and the engineers will know every intimate detail of that gas turbine. You know, the differences in the make and model from the version that we bought last year, the metallurgy differences, speed, rotation. They can recognize vibration signatures. They can recognize temperature variations. But when you ask them about the lubricant that protects their equipment, you're lucky if they know the brand and the viscosity grade. Is my experience at a lot of sites. Not true of all sites, but in a lot of cases, it seems like the knowledge level for lubricants is kind of lacking a little bit.
You know, like, that goes to the heart of is what an interesting topic. I can't tell you how many times I sat down in the control rooms at a power plant or someplace, and I start asking questions, and I don't know how to run a power plant, but just what temperature, what's, you know, and then they start giving me the answers to this. And I said, well, you got the lube oil analysis? So they pull up the lube oil analysis, and I'm like, well, that's wrong. That's wrong. And it's like, you don't have any baselines. There's no reference standards. You don't know what new oil baselines are. Like, how do you interpret an oil analysis if you don't have that baseline?
Yeah.
What is it supposed to look like?
Yeah.
And I think at least half the sites I've ever seen have no baselines. And it's just like, what? And then this one test here, they're doing this test every month, like RPVOT, that is a $500 test, and they're doing it every month. I was just like, whoa. And you know, that value is not ever expected to change like a particle code. Like that value is going to change so gradually over time. You just don't need to do it monthly, right?
Mm.
And then even on that test, you don't have a baseline on that test, the value is completely meaningless. And how many times have people spent $500 on that test and there's no baseline? It's a waste of money. Yeah. So getting people just the basics, like 5 minutes of education on interpreting an oil analysis report is transformational in terms of what they can do with that information, right?
Yeah, definitely. Maybe just to take a little bit of a step back to resin exchange,
Sure.
filter technology, and maybe a bit more about almost the philosophy of what we're trying to do with that technology, because I guess there are different approaches to managing this varnish problem, right? Where we see across the industry, there are a variety of different solutions that are proposed. Some of it is, putting in additives to resolubilize, the insolubles. Then obviously we've got something like the resin exchange as well. Putting in different additives, putting in slightly different base oils. A lot of those seem to be, how shall I say, delaying the inevitable, right? So if I put a solubilizer in, it can resolubilize a certain amount of those the varnish precursors, if you like, but at some stage I've got to pay the piper, if you like. So yeah, what's the difference in that you guys see in the resin exchange technology in terms of, let's say, extending oil life?
This is a great question. It goes to the heart of everything. You're either in one of two positions right now. You're either managing the chemistry of your lubricants or you are not. And if you're using particulate, filtration, water removal, vacuum dehydration, these are all great things and we need them. But the oil quality, the chemistry is in an unmanaged state. Okay, so you can choose to wait 4 years, 5 years for problems to start manifesting. But those problems are predictable from day one because you are adding molecules to the equation that shouldn't be there. You are complicating the chemistry a little bit more every day. So to wait 4 years and then to use, say, one of these solubility additives to try and dissolve the varnish is just going to complicate the chemistry 10 times more. So it's sort of like moving the ball down the field, but it's not going to really ever get to the goal line. You're making the situation more complex. So what we're doing with ion exchange resins is actually removing the bad actors, removing the molecules that should not be in the oil, so that the remaining additive in the oil, or even the top up oil with new additive in it, is able to be used correctly, right? When you use top up oil right now and you dump it into a system that is full of oxidation material, you just get reaction, and you get complications and you get unpredictability. And it's really not solving any problems. It's just moving the ball a little bit this way and then that way. And you're going to have to, it's going to come home. It's going to come back to get you. So removing it from the equation permanently allows the oil and the additives that were engineered by the oil company to use in that oil to work properly.
Okay. And maybe another question about deployment. So most of these filter technologies, I think, are probably most associated with the turbine and power generation industry. So we most commonly see them in steam turbine and gas turbine applications. And obviously that's where a lot of the focus has been on varnish and varnish precursors and all that kind of stuff. Do you see this technology being more widely adopted in other applications in the future? Obviously we see it a little bit on hydraulic systems, but sort of reaching further afield to other industrial applications. Do you ever see it being, I don't know, miniaturized for use elsewhere? Or is it the nature of power gen that you're dealing with such expensive assets, such huge oil reservoirs, high temperatures that result in varnish, that's where most of the focus is going to remain?
Well, there's some truth to that because of the value of the production equipment, right? So it hurts more if you're losing $1 million a day than it does if you're losing 10,000 a day. But I would say that, like, if you move into, say, hydraulic systems, some of these hydraulic systems used in general industrial applications are as sophisticated as what's in a power plant. It's just the only thing that's different is the production value.
Yep.
Okay. So if this machine goes down, it's causing problems, but it's just not $1 million problems, but they can be very real and very acute problems depending on the facility. There's a lot of critical industrial machines used, and they're just banging out product on a regular basis. And it's so important that those machines work properly. So I would say that it's not a miniaturization of the technology because it's really proportional to volume, right?
Yep.
And the industrial systems will have, well, it's based on their volume, the similar sized equipment. So really the situation becomes, how do we tune the technology and price the technology accordingly so that it can work in that application? And it is. There's lots of critical applications out there in general industrial facilities, and we are working in that area. So I think we're the first, and I'm quite confident about the future in it. There's just too many operating problems. Varnish is not a problem for the power industry. Varnish is a problem with all lubricants used anywhere. And if you let those lubricants accumulate oxidation material past the point of saturation, you have solid varnish, okay? It's that simple. So if you keep the oil in an unsaturated state, you can't have varnish. And that's what the ion exchange resins do. So no, it has broad applicability in industry with a variety of lubricants.
Okay. And maybe continuing on that theme, what do you see more broadly as being the future for filtration technologies? So, we sort of went from, if you think of the evolution of filtration, it was just a mesh screen, and then depth media came along, and then we have, obviously progressing through to this kind of resin technology. Is there a next step?
There is actually, and it's sort of, it's interesting. Great question. When I talk about contamination, we talk about solid contamination and water contamination, and then we have the dissolved contamination. And I'd say they're all equally important, right? On the particle side, what's interesting to learn is that conventional filtration is only removing 10% of it, right? 90% of most solid material is below the range of all filtration. Even depth filtration only gets down to about 1 micron. So we like patch weight testing, because patch weight testing, you can't hide behind it. And looking at the mass of the contaminant in the system relative to where it should be is a really good starting point. So depending on the sophistication of the application, you can go down to 1/1000th of a micron by using electrostatic oil cleaning technology. And that's going to be application dependent where you need that, right? So I think there's so much we can do on the solid contamination removal, because we're really only removing about 10% right now. When we move into water contamination, I think the industry's got a really good handle on this, and dissolved water, emulsified water, free water, vacuum dehydration is a great technology when you use it in the right space. The question I find people having difficulty with is, what is the rate of ingress? So don't apply a machine that will take out 2000 ppm a day on a system that's only has 40 ppm ingress, right? So for the most part, we're doing great on water. Now on the soluble side of the equation, the dissolved contamination, there's barely any work being done in this area. And this is where all the problems are occurring, right? This is the root cause of oil failure, is on the dissolved side of the equation. So we need to get there. We need to get there as soon as possible. Start managing this wherever we can. RNO oils, AW oils, jet lubes, phosphate esters, quite a wide variety of lubricants. And wherever that's required to manage it, right? If you can manage the chemistry of the fluid, incredible things happen in terms of the life cycle and the sustainability of the products we're using, right? These products can last years and years and years if we treat them like assets and not as just disposable consumables, right?
Yeah, I'd really like to sort of pick up on that point, but just going back to the water ingress, it's interesting you talk about looking at the rate of ingress versus what the systems are designed for, because you're right. I've worked with a couple of power plants, notably the top end of Australia, and a little bit in Southeast Asia, and the humidity is so high in those areas, well, that even with some of the vacuum dehydration technologies, they keep just putting on larger and larger skids, and they still really struggle to keep up, just because of you're right, like the rate of ingress is so much higher, just because of they're working basically in 100% humidity all the time.
And that's not necessary to have all that pain and suffering. That is the simplest thing to solve. And everybody looks at me like I'm from Mars when I tell them, well, why are they doing that? Like, why don't you just put a dry gas blanket or a small nitrogen generator on there and reverse that cycle? And they're like, you can do that? And it's like, yes, nitrogen generation was not the best invention in the 70s, but it was a good one. And we can make nitrogen wherever, like we're breathing 70% nitrogen right now, more than that actually. To put that on top of lubricants in humid environments is gold. You can triple, quadruple your life of your lubricants with that one step alone. And not only that, I was at a site near the ocean at a big power plant, and they manifold their breather elements. So they have like 6 of them, right? Because they only last like 3 or 4 days, right? So I'm like, what are you doing? Just reverse the flow of this, put a dry gas blanket on there, and exhaust out the breather element, preferably with nitrogen because it's inert. And you know what? It also regenerates the breather elements. Now, I've always been waiting for the breather element hitman to show up at my door and say, you're costing us too much money by putting nitrogen on systems, but we're not trying to decrease the revenues of the filtration business. Quite the opposite. It's like, if we can put the customer in a position where they can make some success and eliminate some problems, guess what they're going to do? They're going to keep on going and generate many more sustainable initiatives at that same company, right? And there's 1,000 things every company can do to be more sustainable and to improve actually the bottom line. And it all starts with, you have to get some small victories, right?
Yeah.
If If they don't win the first few, they're just going to give up and they're not going to try anymore. But putting nitrogen on top of hydraulic systems or lube oil systems in humid environments is the biggest no-brainer in the filtration industry could ever do. Like, it will happen everywhere eventually, right? Everywhere.
Mm. Yeah, that's really interesting. Yeah, so now to go back to the point that you were making about treating lubricants as an asset. Now, I guess I'd like to get your take on why do you think it has been so difficult with many of our customers to sell that idea. In my experience, actually, you know what? I'm not going to talk about my experience because that'll be leading the witness. I'll let you answer the question.
You know what? It starts with a mindset change. And right now, I understand where they're coming from, because I always get the phone call, Peter, my oil's halfway dead. What do we do? And to try to convince the boss to spend money on a half dead oil seems counterintuitive, right? No, the question they always look at is, well, I'll just replace it. If it's more than 50% of the price of the oil, then I'm just going to replace it. You can't look at oils that are half dead as not being worth investing in. You can change the oil and start over if you want, but I'm going to say don't prematurely dispose of that oil. It's just the sooner we can get a chemistry solution on that oil, the longer you're going to be able to extend the oil. So our approach is really, instead of adding additives, aftermarket additives into your lubricant to try and delay the inevitable for a year, it's like, let's put ion exchange resin technology on there to manage the chemistry, manage the acid number, and then we're going to stabilize the rate of breakdown. We're going to reduce how much additive is consumed year over year, right? And really transform the situation. If you can add top up oil of whatever brand you're using right now, if you can add 5% new oil on top of a system that has the chemistry managed, good things will happen. Right now, you put in 5% top up of brand XYZ, it's not going to have any effect, because it's going to react on the very first day with the accumulated garbage in that system, and it's going to waste it. But if you can manage the chemistry and remove all that reactive material from the oil, then you're not going to have that. So I think the industry has a real incredible opportunity to change the game for themselves, but they just have to stop looking at the question as, well, should I spend this much oil, or should I spend any money on an oil that's half dead? And the question is, well, maybe not. I'm going to advocate that you should, but let's start earlier next time, right?
Yeah, that makes sense. I guess one of the things that I've always wondered though is, let's say, for example, as a supplier, whether you're a lubricant supplier or a filtration supplier or something like that, it always seems to be, again, this is just my opinion, more difficult to get the ear of, the maintenance superintendent or
Sure.
even the procurement officer than it would, let's say, if I were a bearing OEM, right? For some reason, it seems like hardware, physical hardware that I can see, always seems to trump the value that lubricants brings every time. Now, that's not to say that can't change. But again, just in your opinion, what do you see as maybe being some of the levers that as an industry we can try and pull to put forward the value that we can bring to these organizations?
I think, and this is going to come out a little overstated, but if you want to get dramatic effect with your customers, just tell them that 100% of the maintenance you're doing right now on your lubricant is targeting 0% of the problem, and our job is to turn that upside down, and that's get that existing maintenance spend focused on the root cause of the problem. Okay, and then you're going to save a ton of money. And plus, most importantly, you're going to not have any failures, and you're going to look like a hero at work. We used to laugh. I've had 3 or 4 instances where customers have got a job promotion, And, I can't promise a job promotion by managing lubricant quality, but you know what? You look good to the boss if you start managing the cause of failure, right?
Yeah. Yeah. Yeah, definitely. Yeah, it's just it's an interesting challenge, I think, for the industry. And
there's a lack of training. So what
yeah,
you're doing here is incredible because people, let's just put it this way, net zero 2050 is an impossible target unless everybody starts doing something different. And I was saying, for almost a million years, humans have been burning fossil fuels to feed themselves for security and to control their own destiny. And in a twisted sense of irony, we're left in the same position now. To control our own destiny, we need to be more sustainable. We need to figure out better ways to do everything that we're doing. And there's thousands of things that we can do. So let's stop waiting for somebody to solve the problems and let's just solve them ourselves, right? Why are we waiting for our politicians? Like, there's no way a politician is going to solve this problem for us.
yeah,
Let's take matters into our own hands and let's fix what we can fix. Let's learn however we can learn, and let's employ some of this learning into improved maintenance strategies, right? It seems like the industry, and it varies from site to site, but the industry has a amazing potential in terms of where their starting point is. The baseline is so low, the expectations are so low right now, right?
yeah,
If we can transform some of these businesses and get some of the young people coming up to actually change their companies and influence change to more sustainable practices, like incredible things are going to happen. Every dollar saved is a dollar that's saved every single year. So
yeah.
if you would reinvest that $1 in sustainable approaches, good things are going to happen. So we do need to look at a longer term perspective, and oil is definitely not a disposable, consumable over and over again. Like, people are doing it right now because it's easy and they don't know a different way to do it.
Yeah. And timely. I mean, obviously with COP26 having just finished, I think now is probably the time to sell the idea that lubricants need to be part of your strategy. Pretty much all businesses that I work with anyway have signed up to some kind of decarbonization strategy, whether their timeline is 2030, 2040, 2050, it doesn't really matter. But yeah, I think that's a really good angle to take. If you can take that sustainability angle, then I think we can potentially make a lot of headway there. So
what we do in our homes and our personal choices is really just unfortunately limited. Like, we can make all the right decisions at home and it's going to have barely an incremental approach, right? But if at work, if we can influence change, incredible things can happen. Like, we have some of these large power plants we work with in the world are burning equivalent to 1,400 rail cars of coal a day. Like, that's incredible. Like, can you imagine the optimization that can occur if we focused on, 5 or 6 of these facilities on Earth and actually made them more efficient? Like, incredible. Yeah. So I'm really excited, actually. Some people are pessimistic on this and they don't want to acknowledge it, but business is going to figure this all out. Business doesn't need politics to figure things out. The dollar figures things out. So as soon as the game is understood, as soon as the taxation and economics are established, business is going to solve this problem. But and they're going to do it probably quicker than anybody thinks.
Yeah. Yeah. Well, that seems like a really optimistic note to end on. Mr. Dufresne, thank you so much for your insight, both on obviously the filtration technology, resin media, but also on this idea of how do we change maybe perception in the industry to view lubricants and lubrication management as more of an asset management type activity. So, yeah, really appreciate your time and thank you very much.
Thank you.